Hello, class. This is Mr. Eggleston, and this is the ultimate lesson, lesson 7.8, solving quadratics using symmetry, which is basically introducing you to the very famous quadratic formula. All right, and the premise of this is that a parabola is symmetric across the axis of symmetry. That is, if you know where the axis of symmetry is, and you know one of the zeros, and you know that distance from the axis of symmetry to that zero, you know there's another one, another zero on the opposite side of the axis of symmetry at the same distance away. So it's about the idea that the distances between the zeros of a quadratic and the axis of symmetry are equal or equivalent. So we're going to find the zeros by identifying the axis of symmetry and calculating the horizontal distance, and that's the trick right there, the horizontal distance. Being able to calculate the horizontal distance between the vertex and the x-intercept. All right, so your basic idea is this. Here's a parabola. Here's the vertex. The axis of symmetry is this line that goes right down the vertex. What they're saying is, even though this isn't a well-drawn parabola, that this distance from the axis of symmetry to the x-intercept is equal to this distance, that they are equivalent. They are the same value. They are congruent. Lots of math language there. All right? And the trick is we know how to find the axis of symmetry, the AOS. We already know that. That's H equals opposite of B over 2A when it's written in f of x equal to ax squared b plus bx plus c in what we call standard form. So there's our axis of symmetry, and all we have to do is figure out what D is. And there is an equation for it, and it's kind of a crazy equation, but it basically, they don't prove it, is the square root of what they call h squared minus C over A, where the letters C and A and B are all based off of the function written like that. All right, so let's get into this without further ado. Okay, so scrolling down, here we go. So a parabola has a vertex at 2, -5. So 1, 2, 1, 2, 3, 4, 5. So we're right there. And the horizontal distance between the vertex and an x-intercept is 4. That means if our axis of symmetry is right here, our AOS, remember this is x equals 2 is the axis of symmetry. If there's the horizontal distance between the vertex and an x-intercept is 4, that means we count 1, 2, 3, 4 and put a dot there, because that's where the graph crosses the x-axis on that side, and we can do the same thing to the left. 1, 2, 3, 4. And there's another point right here. So we know the parabola is going to do something like that in a really rough manner. All right? So there's a rough sketch of this scenario. Find both x-intercepts. So clearly demonstrate. I found, or how do I say this? I plotted the AOS and then counted 4 units to the left and right of the AOS, the axis of symmetry, and that was do I say? It's not that. And 4 units to the left and right of the axis AOS, and those were the x-intercepts. So I'm going to write them down now. They were, since the AOS was 2, one of the x-intercepts was going to be 2 plus the 4 units, which is 6. Another x-intercept was going to be the 2 minus the 4 units, and that equals -2. So our x-intercepts were at 6 and -2. Now, on the second part, Janice was given an equation for a parabola. Unfortunately, her calculator is broken, and it only shows half the parabola when she graphs it, as seen below. Can you help her figure out the missing information? What is the x-coordinate of the vertex? Well, here is your axis of symmetry. So the x-coordinate of the vertex is x equals -4. What is the horizontal distance between the vertex and the x-intercept? They want this distance here. They want this distance there. So what we know is that if we have a distance of 4 to the AOS, I'm not really caring that it's a -4, it just means it's to the left, and that the x-intercept is a distance of 1.764 from the origin, right? This distance is 764. Then the distance D would be equal to 4 minus that 1.764. And when you do that, that equals 2.236. You might want to double check that with a calculator. Take 4 and then subtract 1.764 from it. All right? So that's the horizontal distance from the axis of symmetry to one of the x-intercepts. So the other one will be d units this way. So if it's 2.236, there's going to be another, how do I do this? Well, let me just show that to you. It would be the -4 minus the 2.236, and that works out to be -6.236. -6.236. So there's another one. And the graph is going to look something like this. Okay? So, and this point where it crosses is -6.236, 0. So you notice we found that distance D between the axis of symmetry right here and the x-intercept. We found that distance and we just added it to this one, or actually subtracted it because it's to the left, to find this point. All right, so because they are both symmetric, they are both D. Now, the equation Janice was trying to graph was given by this. F of x equals x squared plus 8x plus 11. Let's see how we can use this equation to identify the intercepts even if we don't have a graph. Notice, they say remember that the standard form of a quadratic equation is ax squared plus bx plus c. So you want to have to remember that because you need to know what a is, what b is, and what c is. Well, looking at this equation up here, this one right here, we see that a equals 1, it's the number in front of the x squared, b is equal to 8, the number in front of x, and c is equal to 11. Okay? Now, calculate the x-coordinate of the vertex. Let's call this value h. So, h is going to equal the opposite of the b over 2a. That's just the x-coordinate of the vertex. b is 8, so it's negative 8 over 2 times 1, which equals negative 4. Okay. Now that we got the x value of the vertex, we can calculate this expression. This is the distance d from the axis of symmetry to an x-intercept. So right over here, d equals the square. They don't tell you how they came about it because it's a little bit advanced for you guys right now. But they're telling you that that is the distance, the horizontal distance from the x-axis, or from the axis of symmetry to a 0. So maybe I'm jumping the gun because I think you will get the right value here. So it's going to be equal to the square root of negative 4 squared minus, now remember, c is 11 and a is 1. Okay? So we have that. So this equals the square root of 16 minus 11, which equals the square root of 5. And the square root of 5, numerically, using my handy-dandy calculator, is 2.36. 2.236. It's an ugly decimal, but that's the gist of it, 2.236. Okay, what does that value represent? This is the distance. Okay? The distance. The x-intercept is from the axis of symmetry, AOS. Okay? So if that is the distance, how can we find both zeros of this function? Well, we could take the vertex, h, location, so an x-intercept, and then add that number, distance, and then subtract that distance. So x-intercept would be equal to h plus d, and h, and x-intercept, another one would be h minus d. So we would have h, which is 4, negative 4, excuse me, minus 2.236, which equals negative 6.236, or another x-intercept would be h, which is negative 4, plus 2.236. Okay? And negative 4 plus 2.236 is negative 1.76. Okay? And if you look, that's exactly the numbers that they gave us up here, right? They said that right here is blah, 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 blah. We were able to calculate this distance and that distance. Okay? Those are the two x-intercepts. So they give you, for each of the quadratics, find the vertex. and the horizontal distance between the vertex and an x-intercept, then find both x-intercepts. So here's the equation right here, the first one. Y equals 2x squared plus 2x minus 17.5. A equals 2. B equals 2. C equals negative 17.5. So the vertex occurs at, this is H. Well, they call it X, but it's really, they're going to refer to that as H in the formula. So X equals the opposite of B over 2A. So that's going to be the opposite of B is negative 2 over 2 times 2, which equals negative 2 over 4. Which is negative 1/2. Okay? Horizontal distance between the vertex and x-intercept is always going to be the square root of h squared minus c over a. All right? So that horizontal distance, and this x here is h, so h equals negative 1/2. So this is going to equal the square root of negative 1/2 squared minus, our c is a negative 17.5 over 2. All right? Well, if you calculate this out, this works out to be the square root of 9, which is equal to 3. Okay, and you can use calculator to evaluate. Use calculator to evaluate that. Okay, so you get x equals 3. First x-intercept would then be h. Let's just say h plus 3. H was negative 1/2 plus 3. Negative 0.5 plus 3 is it's 3 minus 0.5, it's 2.5. Use a calculator. And the second x-intercept would be h minus 3, which would be negative 1/2 minus 3, which equals negative negative 3.5. And we found the two x-intercepts. Okay. Now, same thing for this one. A equals x squared minus 6x plus 3. A equals 1. B equals negative 6, and C equals 3. So the x value of the vertex is x equals opposite of B over 2A, plugging in our values. Opposite of negative 6 is 6 over 2 times A. So that is equal to 3. So H equals 3. And then the distance, which is h squared, 3 squared, minus c over a, c being 3, a being 1. We end up with the square root of 9 minus 3, which equals the square root of 6. Okay, you could get a decimal estimation of that, but we're going to write the exact answer. So the exact answers are going to be, well, one of them is going to be h plus the square root of 6, because that's d, and h minus the square root of 6. So that's going to be, h was 3, so it'll be 3 plus the square root of 6, and 3 minus the square root of 6. Those are the exact answers. If you wanted to get a decimal approximation, you could use a calculator. So I'm just going to give them to you. 3 plus the square root of 6 is 5.45. So this is about 5.45. And then 3 minus the square root of 6 is about 0.55. 0.55. Now, this is exact, the one that has the square root. This is approximate, because whenever you evaluate these non-perfect square roots, you get this ugly irrational decimal. So it's definitely an approximation. All right? All right, now I can honestly say that I like this formula a lot better than the actual official quadratic, because there's less moving pieces, if you will. There's less things, letters involved. All right, so I do like this method, although when you go off to higher level math like Algebra 2, we just give you the official quadratic formula. So let's finish this off. Let's do the last one. A equals 3, B equals 24, and C equals 48. So let's find our H value, our vertex. X equals the opposite of B over 2A. So that's going to be the opposite of 24 over 2 times 3. All right. Negative 24 divided by 6 equals negative 4. And that's H. So now we have the square root of H squared minus C over A. I just like to write this so you can remember it. That's going to be the square root of negative 4 squared minus C in this equation was 48 over A is 3. So it's minus 48 over 3. This equals 16. The square root of 16 minus 48 divided by 3 is also 16. And we get the square root of 0, which is 0. So the distance between the vertex and an x-intercept is 0. That means there's only one x-intercept. And that's going to be at negative 4. Because it's going to be, remember, it's going to be H plus D and then H minus D. But H is negative 4 and D is 0. So you get one solution. Doesn't matter if it's plus or minus. Negative 4 minus or plus 0 is negative 4, and negative 4 minus 0 is negative 4. You get only one intercept. And that's kind of important, okay? What that means is vertex is on the x-axis. Okay? So there you go. Here's our quick notes. And then I'll turn this off and start another video for the CYU. To find zeros of any, notice they underline that, any quadratic equation, okay? Any quadratic equation, calculate the vertex, which is H equals opposite of B over 2A, and the distance between the vertex and x-intercept, which is given as the square root of H squared minus C over A. The zeros will be H plus or minus D. And they want you to leave your answers as exact. They want you to keep the square roots. Okay? So there you go. And now I'll pause this and we'll go on.